So we're going to go ahead and use what we know about quadrilaterals to answer some questions. So we learned about some quadrilaterals. Remember that we have a whole bunch of properties about quadrilaterals, and then we also have some definitions of quadrilaterals. So we're going to go ahead and use those ideas from the properties and or from the definitions to be able to prove things when they're drawn on a coordinate plane. So when they are graphed. So the three main things we're going to be using are at the very top of your paper. So make sure you get your paper. It should be 2 sheets of paper, actually. One of them should have space with graphs and some space to write, and the other one should have 6 problems. So make sure you get both of those papers. So at the very top of the paper, you might want to note these 3 ideas with the stars. So the first one says, on graphs, check for congruent sides by finding the lengths and distances using the Pythagorean theorem. Remember how we make some fake right triangles if we need them in order to be able to find the length of missing parts. So length and distance are the same thing. So the length from me to the other side of the room is the same as the distance. So if you see length or distance, it means the exact same thing. So in order to look for congruent sides, we're going to use the Pythagorean theorem. Don't forget to make right triangles and use a squared plus b squared equals c squared. On graphs, we also can find parallel by looking for the same slopes. Remember, if they have the exact same rise over run, then that means their slopes are the same, which means the lines are parallel, which makes sense because same slopes means they're slanted the exact same way. So if we have 2 lines that are slanted the exact same way, like that, then we can tell that they are parallel. And the third little star says on graphs, we're going to find perpendicular. Also, that means right angles. So things that are met perpendicularly, like this, we can tell things are perpendicular. They're going to form right angles if they have opposite reciprocal slopes. So remember, we're going to be looking for opposite reciprocal slopes, which means we're going to change the sign and flip it upside down. So opposite and reciprocal. So make sure you do opposite and reciprocal. I'm going to go ahead and circle that because sometimes you guys just like to do just one of them instead of both. So change the sign and flip it upside down. Okay, so those are the 3 things that are most useful when you're trying to prove different shapes or get information about something on a graph. So we're going to go ahead and do number 1. Keep in mind all of that stuff at the top of your sheet. So number 1 says we have rhombus F, G, H, I, and has the vertices at F, G, H, and I. It's given there. And how can we prove that it is a rhombus? So the first thing I'm going to do, I'm going to go ahead and answer this question. How can you prove something is a rhombus? So we can look at information we have about rhombuses. So we have all sides are congruent. We have the diagonals bisect each other. We have opposite angles congruent. And we have diagonals perpendicular. And we have consecutive angles supplementary. Okay. And we can also see, since it's in the tree, that it's coming from a parallelogram, which means it's going to have opposite sides parallel. 2 pairs of parallel sides. So the 2 main ideas about a rhombus are opposite sides parallel and also opposite all sides congruent. So let's go ahead and write that. We can also look at our definitions to get ideas. So it says rhombus is a quadrilateral with 4 congruent sides. So we need 4 congruent sides, but we also know that it is a parallelogram. So parallel and congruent, basically. So let's put those 2 ideas here. So how can we prove it's a rhombus? So all sides congruent. That means same length. So I'm going to put in parentheses, length. We have to find the lengths. And if we look up at the top of our paper, length means congruent. Lengths and distances, we're going to have to use Pythagorean theorem. So we know we're going to have to use the Pythagorean theorem. Okay, that's the first thing we're going to have to do. And also, it is a parallelogram. Remember in the tree? So we need opposite sides parallel. So those are two things we have to make sure that we prove. And if you look up at the top here, how can we prove parallel? Parallel by looking for the same slope. So we got to count rise over run and get same slopes. So we need same slopes. Okay, so those are the two things we're going to have to do. All right, so then under here it tells us find the slopes and the lengths of each side. So let's go ahead and do that. So I'm going to go ahead and graph it now. So F is 1, 2. You have graph paper, so graph with us. You can even pause the video, graph it, and then start it up and make sure you graphed right. Over 1, up 2. That is my F. Over 4, up 0. That is my G. Over 1, down 2. That is my H. And back 2 and up nothing is my I. Okay, so I have my shape here on my graph. I'm going to go ahead and draw it in green. Okay, so you can see all 4 sides of it. So we need all of the sides congruent, which means we have to find the length of all 4 of these sides and make sure they're exactly the same. And we put a little note here, in order to find lengths, we got to do Pythagorean theorem. Now, none of these are horizontal or vertical, so we cannot count bubbles. Instead, we're going to have to make 4 fake right triangles. Okay, so let's go ahead and make my first fake right triangle. So to do this side here, I need a fake right triangle. Boom. Boom. You see my fake right triangle? Okay, let's go ahead and get some side lengths. So this is 2 bubbles, 1, 2. So that's a 2 by 1, 2, 3 bubbles, 2 by 3. So to do Pythagorean theorem, this is why you have all this space on your sheet of paper next to your graph, because you're going to have to do a squared plus b squared equals c squared. So that means I've got 2 squared. I'm going to put this right over here. 2 squared plus 3 squared equals c squared. Okay, 2 squared in my calculator. 2 times 2 is 4 plus 3 squared in my calculator. 3 times 3 is 9. Oopsie. Equals c squared. These are on the same side. Combine, I get 13 equals c squared. Remember to undo a squared, I need to square root. So in my calculator, make sure you do it with me. You should be hitting the second x squared button, and that gives you the radical with the parentheses, and put a 13 in there, and you get 3.6 approximately. So C is approximately 3.6. On my calculator it says 3.605. So this length is 3.6 approximately. Now remember, I need all sides congruent. That means I need to check all of my sides. But let's just take a look at something here, because we're about to save some time, because you're like, oh my gosh, do I have to do this 4 times? And you kind of do, but let's go ahead and make our second fake right triangle, because we might see something. So from F to G, remember I can make my fake right triangle outside or inside. I'm going to go inside and mix it up a little bit. You see him? But look right here. What's going to happen when I look at this side? This is 2 bubbles, 1, 2. And this is 3 bubbles, 1, 2, 3. Hello, looky there. I already did this fake right triangle, and I got 3.6. So I don't even have to do it again. 3.6 is the length of this. Now, obviously that's only two sides, so I do have two sides congruent. So let's check these sides down here. That means I need another fake right triangle. So I got to do this as a diagonal, so I can go inside or outside. Boom. And what's going to happen here? This is a 2, and that's a 3. So what's the length? 3.6. My last fake right triangle. You look at there. I've got 2 and 3. So if I did my Pythagorean theorem again, I would still get 3.6. So it looks like all of my sides and all of my angles, check. That works out. All of my sides, not angles, all of my side lengths are 3.6. I actually don't know anything about angles just yet. So I do have all sides congruent. But I also need the second part. I also need opposite sides parallel. So I need these opposite sides parallel too. So I need to have same slopes. And remember, opposite sides. I'm going to be looking for opposite sides. So let's take a look at opposite sides. Let me see if I can get a different color highlighter. Let's see if I can do this one. Okay, let's do this side and this side. Those are opposite sides, right? We need to see if they're parallel. Now, that means same slopes. And remember, to find slopes, you count rise over run. Be very careful with your negatives. Remember, things that are uphill are always positive. Downhill are always negative. So let's check the slope of this one right here. So it looks like with my right triangles, I kind of already counted slope. Because if I start down here, that's a rise, 1, 2. So I've got a rise, 1, 2, 1, 2, and then run, 1, 2, 3. So the slope is 2/3, rise over run, and it is uphill. It is both, they are both positive. Now let's check the slope of this one. So the slope of this one is 2/3. I'm going to put 2/3 right there in red. Remember, slopes are fractions, rise over run. You can tell the lengths by, if I have this 3.6, you can tell that's a length because it doesn't look like a fraction. So let's look at this one. Now the same thing's going to happen here. I can start at one end and count my rise, 1, 2, and my run, 1, 2, 3. So it looks like I'm rising 2 and running 3 for this one also. So rise 2, run 3. It's uphill, it's also positive. So I do have opposite sides parallel with these two blue ones. We gotta check the other ones too. I will do them in yellow. So let's check this line segment and this line segment. Okay, these are both downhill, so I'm going to be getting negative slopes for those, right? And remember, the variable for slope is m. So I have a m equals 2/3 for that one, and I've got m equals 2/3 for that one. So let's do the yellow ones. Okay, let's, if I go at my, it doesn't matter which end I start at. I'm going to start right here and rise 1, 2, and run backwards 1, 2, 3. So for that one, I'm going to be rising 2, and I'm running backwards 3. So that's a -3. And remember, you can move your subtraction or negative sign up to the middle, so that way it looks just like -2/3. That's cool. Remember, you can, if you have one negative, you could put it on the top or the bottom or the middle, and it all means the same. Don't add extra negatives though. So the slope of this part over here is -2/3, which makes sense. He's downhill, decreasing graph, so negative is what we should have. Let's look at this yellow piece. I'm going to go ahead and start at this point right here. Rise 1, 2. Run -1, 2, 3. So once again, I have rise 2, run -3, and so I still get -2/3. So you see how I have matching slopes and matching slopes. So I do have opposite sides parallel. So that means that this is, in fact, a rhombus. And it says find the slopes and the lengths of each side. So if we want to put an answer on our paper, we can say the length, all sides, all side lengths are approximately 3.6 units long. We don't know what these units are. Okay, and then slopes. So it looks like we had for slopes. We have a segment I to F and I to F, this is the blue one, and then H to G. We have M equals 2/3. And then, let's scroll down a little bit. And then we have the slopes of the yellow pieces, which were I to H and F to G. So we had I to H and F to G. The slopes were -2/3. Sound good?